Welcome to the Stormsurf video surf forecast for the week starting Sunday, June 18th. Looking at significant wave heights for the South Pacific Ocean, we see a gale developing south of Tasmania, 31-foot seas tracking to the east. Development is expected. Let's get into the details. As usual, we'll start this week's tour looking at jet stream level winds. These winds help support gale formation when those gales do form, help direct their track. We're looking for troughs, that is a dip in the jet stream pushing to the north. There is sort of a dip here, but not really. All there is wind, 130, 140 knot winds pushing under Tasmania and a little bit further north than what has been in this area, allowing a little bit of a gap. And as you saw in the previous chart, it is assumed that some level of gale is developing here. But over the rest of the Pacific Ocean, we see the southern branch of the jet ridging hard south, pushing over Antarctic ice down around 70 south, sweeping east, and basically locking down the entire South Pacific Ocean from gale development. The northern branch is running east on about 26 south latitude line. When you have this split jet stream flow, typically what you end up with is high pressure in between the two branches of the jet down at the ocean's surface, and that does not bode well for gale development. And that's been our situation for a while. There just hasn't been a whole lot going on in the southern hemi. Roll this out a couple days into Monday, and you see something that almost looks like a trough here, but the general trend is sort of to the southeast. You really want the jet to be lifting to the north, and we don't see that. Still, some gale development is possible in this region. And as we get into Tuesday, though, that pocket of wind energy starts falling south and pretty much joins the regular flow here, southward displaced, and probably not real supportive of gale development. Another little trough tries to develop under New Zealand on Wednesday evening, has no wind support, and it too shuts things down. And then you just end up with this ridging pattern again, and look at this, just pushing hard south into over the Ross Ice Shelf on Saturday, and just no support. Now notice here, a little bit of winds pushing to the north. That's 162 hours out. But again, pretty much out of the swell window. And at 180 hours, we see nothing but solid ridging to the south. Nothing that would support gale development. Let's go take a look at surface pressure charts. Here we go. Surface level pressure, surface level winds as expected. High pressure there. Little bit of an upper level or a mid-level low here, but notice the main focus of the energy follows the jet stream here, southern branch of the jet stream, well displaced well to the south. Here's our gale that's developing. Actually, it's a storm. Notice there's a little tiny notch of 50-knot winds there under Tasmania, and let's just roll this out. It develops 55-knot winds and almost starts moving east a little bit late Sunday night, but the general trend is taking this route to the southeast. So that means even these winds, if they are pushing northeast, they're falling southeast, and that doesn't bode well for pushing energy, swell energy in particular, off to the northeast towards our forecast area. That gale fades. Another gale tries to organize on Tuesday, same area, and it does the same thing, falling southeast. Doesn't get a whole lot of traction. Another gale on Friday, same region, pretty much shadowed here by New Zealand. It too falls to the south. Look at this. Hard south winds, 45 knots over, what is that? 1, 2, 3, 4, these are 600 nautical miles a pop. So you're into 18 to 2,400 nautical miles of south fetch. Not a chance there. Some sort of a cutoff low here in between. Not typically, well, look at that. There are 40-knot winds on supposedly a week out. Don't believe it. These mid-level, these cutoff lows typically do not develop as strong as what is suggested on the charts. Okay, let's go take a look at significant wave chart. Here we go. Here's supposedly 32-foot seas, but we'll give it 31-foot seas south of Tasmania. Now watch the direction of travel of these seas. Pretty much to the southeast. Now we have 40, 41-foot seas on Monday. Do they move to the east? Almost. 43-foot seas on 18Z Monday. Still sort of falling a little bit southeast, but we'll just roll this back. Let's just do a quick. So it's pretty much along that track there, which is an east-southeast track. But still, it's possible that some small swell could radiate up to the northeast. probably more towards California, Central America, less so towards Hawaii. And that system fades out. Now remember, there's a second gale that follows behind that. Little area 36-foot seas. There too, falling to the southeast. Broad, strong system here targeting Tasmania with 51-foot seas and making it into the Tasman Sea. Certainly some swell for Fiji would be possible. U.S. West Coast, probably not so much, or Hawaii. Actually, some energy for Hawaii possible coming up through the Tasman Sea, but typically size on those is much smaller than if it was unobstructed. It gets pretty well filtered here by Fiji and surrounding islands. And then we look, these seas here are all pushing due south, as we saw, and we're at 180 hours out. Here's the cutoff low, supposedly 28-foot seas aimed back at Hawaii. Would be interesting if it actually developed, but not a whole lot on the charts, really. The system that's forming right now is probably our best shot. Now going back in time, Saturday a week ago, a similar system. Look at this. It looks very much like the system that's developing right now under New Zealand. 44-foot seas, and we'll just watch this. It actually goes due east with 40-foot seas, and then sort of fades out. There's small swell in the water from this one. I believe the swell from this has already hit Hawaii or is on the way. It fades. There's a second system that developed here on Tuesday, right up alongside of New Zealand. Small area, seas got to about 37 feet right there, working its way to the north. Energy pushing towards Hawaii, and then it faded. Secondary fetch developed with 25, 26-foot seas, and then that faded out. Also, going back to Tuesday, off in the southeast Pacific, a gale developed. Not a very strong gale, but watch the seas here, and it's actually pushing not north, but northwest. Here you go, right there. Just a tiny little area of 28-foot seas. Now, generally, going due south from Southern California, about 117 west, that'd put you about right here. That's sort of the general cutoff for storms moving in this direction. But when they form off of Chile and actually either push north or a little bit northwest like this one does, it's entirely possible that swell can reach into exposed breaks in Southern California. We're talking a 165 degrees swell angle, so you need to know which breaks are not shadowed by the Channel Islands and can receive that sort of a swell. And actually, it's possible there's a couple of spots in Northern California that can also receive those very southeasterly angle swells. And here, watch the system fade out Wednesday night, and that was pretty much it. Not a whole lot expected size-wise, but Southern California, the other part, notice, it's up here at like 30, actually, we'll go back here just so you can be exact. There you go. It's at 30 south, which is way further to the north than normal, meaning less swell decay and less travel time to the California coast, meaning perhaps a bit more size than what you would expect if the storm was down in here. So a little bit of energy coming from that as well. And just for laughs, we'll take a look at the North Pacific. There's not anything going on. It looks like a little bit of a tropical development off Japan, but that's supposed to fade. And then you sort of watch. This is the more interesting feature here. This is, and we'll get into the wind charts to take a look. Local pressure gradient developing 17-foot seas off of Point Arena, Bodega Bay area on Wednesday, up to almost 20 feet. Now, winds are supposed to get, at one point, they were clocked at or forecasted up to 40 knots, and in close proximity to San Francisco area. So some larger wind swell is possible. There you go, 20-foot seas, solid, right there into Thursday, and possibly an eddy flow, and we'll get into that in a second. We'll show you the charts. And then that's pretty much it. Things fade out. Let's go take a look at the surface level pressure chart. So here we go, surface level pressure, surface level winds, and this is all about wind swell relative to Hawaii and the U.S. West Coast. High pressure here, ridging into the coast. This is a pretty standard sort of summer pattern. Low pressure inland because of heat. That tightens the isobars between the two systems. That creates wind, north winds in this case. And that's where we're at, 18Z Sunday. So that was about 11 a.m. this morning, Pacific time. 25 knot winds. There were waves, shoulder high, chest high today. Junky, nothing great, but there were winds. Those winds built to 30 knots, and then again are supposed to just barely hold at 30 knots Monday, and then build a little bit more on Tuesday, 30 knots. And then the gradient, notice high pressure builds stronger to 1030 millibars and broader to heat high holds inland. The gradient tightens, 30 knot winds. We're into Wednesday now, building to 35 knots. And there you go. There's your 40 knot winds Wednesday night. Now, this is not a large area of 40 knot winds. Also notice there's some fetch here pushing off to Hawaii. We'll examine that in a second. But 40 knot winds within, what is that? About 3 or 4 degrees. So at 60 nautical miles a degree. So we're talking, 180 miles off to maybe 200 nautical miles off from San Francisco or down into Central California. Certainly, wind swell should result. And then the fetch starts moving, aiming a little bit more to the northeast, less focused on California, and so the wind swell would die. Now, we'll redo the same scenario, but we're looking at Hawaii. We're looking at fetch off the south end of high pressure. High pressure rotates clockwise and can produce wind swell. Of course, the high pressure here, the sort of semi-permanent high here in the Gulf of Alaska in the summer months, that generates trades pushing over Hawaii. And if those trades, often they will get strong enough over a long enough fetch, produce pretty decent wind swell pushing into east shores of the Hawaiian Islands. And you can see right there, we get into Monday, 15 knot northeast fetch starting to push into Hawaii, and that continues, aimed even better Monday night into Tuesday, and even a little patch of 20 knot winds off here Tuesday morning. But then the gradient starts fading. It builds here along the California coast, but fades relative to Hawaii, and wind swell from that, maybe not so much. So, and we looked at the models, and we're not talking, just something rideable on exposed east-facing shores. That's it. All right, let's take a look long-term. What's going on with the Madden-Julian Oscillation and El Niño, or La Niña? We start off looking for evidence of the active phase of the MJO. Of course, the active phase of the MJO, when in play, sometimes can help feed storm development in the southern hemisphere, certainly in the northern hemisphere in winter months. We look to the Kelvin wave generation area, that area from about 135 east to about 170 west, right in here, 5 degrees north and south of the equator. And we look for either slack trades or westerly anomalies. We don't see that. We see weak easterly anomalies. There actually had been a little bit of westerly anomalies for the past 4 or 5 days, but they have since receded. Generally, a little bit of west anomalies here, suggestive of perhaps the active phase of the MJO in the far East Pacific, but it's exiting, making its way into the Atlantic, if at all. Here's another way, looking at past performance. Zonal wind anomalies, 850 millibars is up about 4,000 feet. Pretty good proxy for what goes on down at the surface. Kelvin wave generation area, right here. The date line's right here. This is the whole globe on one planet. And you can see in the Kelvin wave generation area in early May, easterly anomalies. These blues, purple, that's easterly anomalies. That suggests inactive phase of the MJO. Here's today's date. Still weak easterly anomalies. That correlates well with what we saw in the previous chart, which was from actual buoys down at the ocean surface. Basically confirming what the models are saying. The forecast, easterly anomalies are to continue for the next 4 to 5 days and then maybe get rather weak, but we see no sign of westerly anomalies for the next week. All this suggests, and this pattern here of consistent easterly anomalies and no sign of westerly anomalies is pretty much a clear indicator of La Niña. Even though La Niña is supposedly not in play in the atmosphere, it looks like it, even though there's other evidence that suggests it's not, but there's certainly no evidence that suggests El Niño is in play. But back to the MJO, looking at the outgoing long-wave radiation model, yellows suggest more sunlight reflectivity off the ocean surface, meaning high pressure, meaning the inactive phase of the MJO. This model, the statistical model, suggests, yes, inactive phase is in control and forecast to weaken over the next 2 weeks, but no active phase. Here it is in the Indian Ocean. This is classic signs of La Niña. So no, the active phase is not supposed to make its way into the Pacific. The other model, the GEFS model, paints an even worse picture. Inactive phase holding for the next 4 weeks. Active phase balled up in the Indian Ocean. This bodes well for surf in the Indian Ocean. Also for Africa. In fact, South Africa has actually had some decent dungeon swell, and there's been a lot of footage coming out of the Indian Ocean suggesting good, solid surf there. But the Pacific, not so much. Phase diagram charts. Assume you're looking down on the North Pole, this circle here, and the active phase of the MJO moves from west to east from the Indian Ocean over the maritime continent into the West Pacific, under the U.S., United States, across the Atlantic on the equator, over Africa and back into the Indian Ocean. The heavy dot is where the active phase is, and it is in the eastern Indian Ocean. And the forecast is this green path. If it falls inside the circle, that means it's exceedingly weak. This is per the ECMF model, but you look at the GEFS model, it says the active phase is basically in the same place, and it is supposed for the forecast for the next week a little bit stronger on this model than on the ECMF, but relative to the Pacific Ocean, no hope for the active phase for the next 2 weeks. Upper level model, okay, so there's Australia, the Philippines, South America, Mexico, and this is multiple panels, 5 days out each panel, so you can get about 40 days out if you believe that. Yellows suggest areas not favorable for precipitation. So this is the main pulse of the inactive phase of the MJO moving into Central America on, let's say, the 3rd of July, but a secondary pulse working its way across into probably in about mid-July. And then finally, supposedly, the active phase of the MJO develops in the West Pacific early July, working its way across, only to be followed by another inactive phase in late July. But right now, it sure looks like the inactive phase is in control and should be for the next, let's say, 2 weeks. Our favorite model here, the CFS model, again, 850 millibar winds, Kelvin wave generation area, right in here. Again, this is the whole planet on one chart. Right in here, and we see, according to this chart, pretty much neutral anomalies. Nothing particularly strong. We can overlay the MJO. Very weak MJO signal. Here's the active phase of the MJO in the Indian Ocean, but it is not supposed to make any progress over to the Kelvin wave generation area. Just this weak kind of pattern, but this model has been consistently hinting that westerly anomalies are to develop in the Kelvin wave generation area, let's say June 23rd or so, and they're supposed to hang there and then build as the active phase finally makes its way into the Kelvin wave generation area. But notice there's these blue easterly anomalies, so there's this line somewhere right around the date line or so. Maybe we can scroll down here so you can see there's the date line right there. So the westerly anomalies are not supposed to make it anywhere but to maybe the date line, and that's it. Anyway, active phase of the MJO is supposed to develop later in July, hold into end of August or so. And then notice there's an inactive phase, very weak, but forecast coming behind that out into September 15th. But notice westerly anomalies hang on. Now, we'll see what really happens here. We have this sneaking suspicion that La Niña is going to come back. In fact, let's take a look. Low-pass filter. So we've been waiting for this for weeks now. The dotted contour is a clear sign of La Niña in the Kelvin wave generation area, and notice it is gone as of now. It faded out on about June 13th or 14th, something like that. It's gone, but look at the forecast here as we get back into August. La Niña supposed to make a return. Now, just a little finger of it here. Most of the energy here this is actually over or just east of California. We'll see what really happens here. Still, the solid contour, the bulk of the energy that would be considered good for precipitation is still supposed to be balled up in the Indian Ocean. So all this basically says a continuation of some sort of weak, indiscriminate La Niña is more than likely moving into this coming fall and winter. We've talked about the MJO. We've talked a little bit about La Niña, El Niño. Let's go see what's going on in the ocean. In the ocean, this is a depth profile West Pacific here, East Pacific here, going down 100 meters, 200 meters. These are the anchor lines on the TAO buoy array, which string the whole way across the equator and are used for monitoring El Nino. And what we have here is our warm water is all balled up in the west, but it's not even that warm. It's just kind of pretty much normal, we suspect. We have the 28-degree isotherm making it to about 148 west. It's been there for about 2 weeks, which isn't bad, but it's certainly not any indication of El Nino. But if it was a strong La Nina, it would be retreated way back here. And we have warm anomalies, 24-degree, or not anomalies, warm temperatures, shallow area 24-degree centigrade temperatures here in the East Pacific. Here's anomalies, differences from normal for this time of year, and it's the upper 100 meters that we're really interested in. What you see is basically a neutral normal pattern. Yeah, a little bit of 1-degree anomalies here in the west, a little bit of 1-degree anomalies here in the east. This was up to 3 degrees at one point. It's since mellowed out, and the warm water that was here is working its way off to the east, being carried by trades. No sign of any Kelvin waves. We have this cool pool at depth at 150 meters. It's not doesn't appear to be doing anything negative, but it certainly isn't helping anything either. Another version of the same chart now suggests, well, okay, we'll give it 1 to maybe 1.5 degree anomalies in the West Pacific, also maybe 2 degrees in the East Pacific, and this sort of flow, which would almost suggest a weak Kelvin wave trying to work its way off to the east. The issue is this water flowing this way, or is it flowing this way? We've actually seen some evidence that says warm water that was here is actually being caught by trades over shallow area and moving its way off to the east, but there probably is some also very weak Kelvin wave, or just a flow, a stream of weak, lukewarm water pushing its way off to the east. That can be better discerned here in this chart. Upper ocean heat anomalies, upper 300 meters of the ocean surface, of course, back in September, October a year ago. La Nina in play, cool waters. This is the West Pacific. This is the East Pacific here. La Nina pretty much died as we got into wintertime. Notice there was a Kelvin wave and a buildup of warm water here. What is that? 1, 2, 3. Oh, here we go. 1, 2, 3. 1.25 degree anomalies off of Peru. Of course, Peru, when that warm water hit in this area, they got a lot of rain, and it was almost like some sort of weird little El Nino event. And then the upwelling phase of the Kelvin wave cycle, cooler water. And now here is another Kelvin wave that this is why we're saying we think that warm water depth is flowing to the east, not a lot, because we're talking this is 0 to half a degree above normal with maybe a pocket of half-degree anomalies. That's nothing. If we were talking real Kelvin waves in El Nino, we'd be seeing 3 and 4 degree anomalies. We're not seeing any of that. So just kind of basically a neutral, weak, and listless pattern. Now looking at ocean surface temperature anomalies zoomed in here. Okay, there is Peru, Chile's down there, Ecuador there. What has been going on? We'll put this in perspective. A couple months ago, a lot of very warm water built up here. Some of it from a weak Kelvin wave, more of it because trades typically here blow from the south, creating upwelling. They were all suppressed. So without upwelling, surface temperatures warmed. Big ball of warm water developed here, and it now is advecting off to the west, and here is the bulk of that warm water. But notice down in here, temperatures are cooling. These temperatures are much cooler than they were a month or two ago, and certainly along the coast here of Peru. Still, you get these sort of pockets of flaring up of warmer temperatures, but they're small. Also, this whole area is cooling as well, suggesting that we're not saying we're going to La Nina, but we're certainly not going into El Nino. If El Nino were developing, this would still be warming. It's not. It's cooling. So no signs of that. The trend for the past 7 days, pretty much holding neutral along here, not getting any warmer, not getting any cooler. These are the same pockets of warm water we saw, and what this really is that we suspect trades were blowing here. Took whatever warm water was here, pushed it up, it sort of got compressed here, and now is heading off to the west. Again, moving into the Niño 3.4 region, which is the main area for measuring El Nino, 120 west to 170 west, 5 degrees north and south of the equator, but not a whole lot going on here. This is an interesting thing, though. A lot of warm water here just off of California, north of Hawaii, working its way towards the Philippines, or at least the trend is for this water getting warmer. We're not saying it's warm. Also a similar sort of pattern here off the U.S. East Coast. And here we go. Here's sea surface temperature anomalies, and you can see here's that sort of, we won't call it cooling, but just returning to neutral sort of pattern here in the southeast Pacific. Still a little bit of warming here, but also pockets of cooling. Just kind of a mixed bag. Nothing really warm, nothing really hot. If you're looking for broad areas of warmth, right in here, so this would be Niño 3.4, and that is, maybe half a degree or so, something like that. Here's that pocket of warm water we saw earlier. This may or may not be related to the warm phase of the PDO. Kind of hard to tell this time of year. It's more in the winter when you see the warm PDO signature. But anyway, still a lot of warm water in general across all the oceans. Not sure if this is due to just heating of the oceans, and that the climatology, what's considered normal, is getting out of date, or whether this is hangover from our big El Nino and just warm water got rearranged in the Pacific. A little bit early to know. Looking at the Niño 1.2 sea surface temperature anomalies, so this is off of Peru, immediately in that area, Ecuador, half a degree above normal. And you can see there was a bit of cooling here in May and early June. And temperatures, here was the big warm, well, this isn't the big warm, this is a recent spike in the warmth. The bigger warm-up was back in the February-March time frame. But anyway, temperatures kind of noisy. That's pretty typical in the Niño 1.2 region. In the Niño 3.4 region, the area that NOAA uses for monitoring El Nino, temperatures 0.508 degrees above normal. And they have been basically hovering right there for quite a while. That's borderline El Nino if it were to go for effectively 9 months, but this has only been happening for maybe 2, maybe 3 months, so we've got a ways to go. And just looking at the charts, it looks like based on the temperatures cooling off of South America, it seems likely that this temperature profile will start falling south at some point in time. Let's take a look at what's going on in the atmosphere. This speaks to both the MJO and El Nino. The Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. If it's negative for a long period of time, that suggests the active phase of the MJO. If it's negative for a really long period of time, that suggests El Nino. Right now, here we go. There's been this run for, about 13, 14 days of, make that more like 18 or 17 days of negative anomalies. That would suggest the active phase of the MJO, but looking at all the models, they say no such luck. But according to this, supposedly a weak active phase of the MJO is in play. The 30-day running average is going slightly negative, -3, -2.98. So that is not really an active phase of the MJO. It's kind of weak. And the 90-day running average, you can use this for looking at trying to determine La Nina or El Nino. Negative, it would have to be down at -15 to be El Nino, and it's not. But it's not positive either, but basically neutral. Just slightly on the negative side of neutral. So we're certainly not going to call that an El Nino. Just pretty much normal. But the real teller here is the ESPI index. Much like the SOI, measures the difference in precipitation between the area north of Australia and here in the Niño 3.4 region, a little bit broader. If the value is negative, -1.78, means there's less precipitation than normal in here. And this often leads what happens in the atmosphere. If this happens 3 months later, this is a trend will follow in the atmosphere. This has been going down. It was almost dead neutral a month ago or so, and now it's dropped to -1.78. I think at the depth of our La Nina last winter, it was at 1.9 or something like that, and it is falling rapidly, suggesting dry air moving into this area, suggesting even whatever's going on with the ocean, there's something that's saying the atmosphere is wanting to go to a La Nina state. And let's talk about that just for a second. We had 2 years of El Nino, then we had an incredibly weak La Nina last winter, and there's probably no, typically the the atmosphere has to balance itself out. If you go in for a long El Nino, and we went through a 2-year super El Nino, odds are you're not going to get off scot-free. We were hoping we would with a miniature weak La Nina last year, but all this and the trend of consistent east anomalies over the Kelvin wave generation area and a failure of westerly anomalies to develop, no matter what the models say, it never seems to materialize. Now this dropping looks like we're setting ourselves up for another La Nina this winter. Not unexpected, really, given where we're at in the big scheme of things. Now, if it's a weak La Nina, that's okay. We really don't want to go into some sort of a super El Nino where temperatures go really cold and off of Ecuador, and that would really just put the oceans in a funk and really not do much for storm development in terms of making swells, but also would shut off precipitation into California in winter months, and we don't want to go there. But we don't mind weak La Nina because sometimes, just like last winter, we got a good amount of precipitation, but that was still a hangover from the 2 years of El Nino before that. We will not be so lucky this winter is the expectation that it'll probably be drier than normal. Here's the forecast from the CFS model for the Niño 3.4 region. So it's been toying around. So here we are, right here, half a degree anomalies. We saw that, in fact, that's true. All our data suggests that's about right, half a degree above normal. And the forecast is for those temperatures to slowly fall to maybe minus 0.15 degrees below normal, which is basically neutral. So this isn't suggesting La Nina. It's not suggesting El Nino either. It's suggesting for this winter just kind of a normal pattern. The ESPI index is a little bit concerning, though, because it's right now suggesting something a little bit stronger. So we're mid-June, and 3 months from now, if it's right, so June to July, August, September, as we get into the fall, somewhere in here, it's suggesting that maybe temperatures might drop a little bit lower than this. The models are mixed. You look at other models, they're saying, some forecasters are suggesting neutral. Some models are even saying El Nino. But then we've seen other independent sources that are suggesting some sort of a weak La Nina this winter, and we suspect that is probably the case. And then finally, the PDO. Where are we going with that? Well, okay, so here's, in 2014, we moved into El Nino. We got positive values. Positive values suggest the warm phase of the PDO. The PDO, of course, is a cycle that runs for 15 to 30 years. We can see 98, 97 we had a good run of positive numbers. So look at this here. You can actually see stacks of negative numbers. That's the cool phase of the PDO into 76 or so, somewhere in there. And then things started warming up, positive values the whole way through to 97, 98. We had a big, massive El Nino. This is the warm phase of the PDO, and I don't remember what that was, 20 plus years, 25 years in the warm phase. Then negative numbers, and here we've been negative, still negative up to 2014. We went positive, and it's been basically all positive. And ESA, January, February, March, April, into May, latest values still positive for this index, suggesting that perhaps we are moving into the warm phase, or the warm phase of the PDO, which of course favors El Nino, favors El Nino, and sort of suppresses La Nina. And of course, that's good for precipitation. That's good for storm development in the Pacific, for the Gulf of Alaska and the Dateline region. Now, so this one index says, as of right now, even though things aren't, we don't have a lot of storm activity, that even though we're in La Nina or some sort of La Nina, the index is still positive. That's a good sign. And NOAA's index, not quite as warm. This is a little bit more conservative, but still positive, suggesting that, and you can see here, we've had a couple little negative readings. This was during La Nina, but basically it's been positive the whole way back. There was the transition, let's say March of 2014. So the trend still is looking good. Let's look at a chart. So here we go. You can see a little bit more clearly here. Here's 75. So here is our last cool phase of the PDO from, was that 1960 roughly, somewhere into about 75, so that's 15 years. And then we were in the warm phase from 75 into 98, so that's another 20-some years, 22, 23 years. And then clearly you can see the cool phase that developed after that. Now, just because you're in a cool phase or in the cool phase of the PDO doesn't mean that you can't have spikes, you can't have El Niños. They just tend to be more muted, okay? The big look at how big this El Niño was here or this was during the big El Niño of 97, 98, and the big one of 82, 83 right in here as well, right there, okay? And so what happens is there's the cool phase of the PDO there, the warm phase, and what happens is the cool phase tends to amplify La Niñas, the warm phase amplifies El Niños. There was our cool phase, and the thought is that we're moving into a warm phase right here. But it's way too early to know that. You need to be, we're, 4 years into it or so, 2014? Yeah, 3 years into it. We need to be about 5 years into it. But if we stay generally on the balance on the positive side here, at that point in time you can say we're in the warm phase of the PDO, but it sort of looks like we are at this point in time. We got to really see what happens this winter. So that's it for this week. 2 small southern hemi swells coming from the southwest Pacific, another small one for California coming from the southeast Pacific. Nothing significant in size, but something rideable at best. Certainly piles of wind swell. That actually kind of might mangle some of that southern hemi swell unless you're in a very protected area. But there is surf. Make the most of it. In terms of the MJO, maybe the active phase of the MJO a couple weeks out, but no guarantees there. Regarding El Niño, La Niña, probably La Niña this winter is what it's looking like, but that's okay. Small price to pay. PDO still looking good, still looking like we're moving into the warm phase. So that's it for this week. Happy Father's Day. We'll do it again next week, same time, same channel.